that are competing this year as well, or competed last year, and there's more this year as well. If you want more information on this competition, there's a QR code to the website that they have. It's hosted in June this year, which is going to be a change from last year, which was in May. All of our planning has been expecting this competition in May, so now we've got like an extra month to work with. But we're sticking with the plan to May and just using that extra slack time, and extra testing time. It's going to be a time trial format, so only one kart on the track at a time is racing. And there's two race categories. One is going to be for pre-mapping. The other one's going to be reactive, real-time category. The real-time is the one that we're doing. That's why it's bolded here. And the track this year is bordered by white lane lines, and the predefined obstacles, which are going to be just like U-Haul boxes, are placed in the track at certain areas so that we can avoid them. Here's some videos of how competition went last year. We'll just let that run, and I'll give some anecdotes about how competition went last year. We were pretty successful last year. We ended up getting third place and won the engineering award. Overall, a lot of our team had a lot of fun. It really meshed. It pulled a lot of us together. With this current e-board. Most of us weren't even on the e-board last year, but we all came to the competition, learned a lot, bonded a lot, and I think that really created a team in a lot of ways.
By most teams, none of us. But yeah, the competition went really well. Besides the fact that during the actual competition, we didn't make it past the first turn, which is sad because in almost every single test run we did, the lighting caused issues, maybe this, maybe that. But overall, it was a good experience. We got a working cart. We brought home some awards, and it was really cool.
Mm-hmm. Yep. So here we are. Here's some pictures of us here. We got those two awards, and we can move on to the next part. Here's our schedule. You can take a look at this. I won't go step by step, but there's our schedule for this year. I'll give you a second to look at it. And here we're going to our common strategy overview.
All right, just going to go through this quickly because a lot of this presentation is going to go through some of these specifically, especially the things that we're changing. But in general, how it's going to go is there's white lines. You're going to detect those white lines. You're going to treat them as polynomials, and then using those polynomials, you're going to plan a path. All right, and then using that path, you generate your commands, what's needed. Those are passed to your control loop, and then CAN bus, motor controller, and then finally down to your motors. And a visualization. This is very similar to the visualization that we had last year. The only difference is we removed a object tracker, and I'll get into why we did that a little bit later. But this is a very general, very beginning strategy visualization, and we'll get into this later. We collected data that was 2 weekends ago. No, last weekend actually. So this is it's kind of a couple pictures we took, and we'll use this data going forward for training and testing and et cetera, et cetera. And start or have ever come up.
So what happened at comp mechanically? So for the first couple days, the cart ran pretty smooth. But then after that, we started getting some issues with the motor. It would stall at random times, and we still to this day have no idea what the cause of this is. There's a quick little video. This is during our testing day last week. The issue resurfaced. There were also a couple other hardware issues, and these issues overall were really hard to pinpoint. And so a big goal for this year. So our goals for this year are the integration of a new BLDC motor, to try and address the issues with the motor. And to overall design components, or design mounting and housings to improve the pinpointing issues with hardware. Uh, so as you know, this is an iterative project. So we started off with this stock go kart from Top Kart, and the powertrain remains the same. The hydraulic brakes also remain the same. The motor controller that we use now is a Robotech, it's not an Outright. And the batteries have been swapped for longer lasting, higher amp hour batteries. And you can see this is our new car, or this is our current Phoenix. And you can see the fun weight distribution and our overall weight, which is 404 pounds. This is our current motor and speed controller on the cart. So these are some specs. I'm not going to go into too much detail. This is for our current motor and our current motor controller, the Robotech. So why are we swapping our brush DC motor and motor controller for brushes? The main reason for this swap is the issues that we're facing right now, which are not able to be pinpointed at all because of the discontinued Robotech. Our current motor controller, the Robotech, the firmware is out of date, and so there's no way for us to check the log files and see what's going on. There's also very little documentation and virtually no support for the motor and the motor controller that we are using right now. So a big benefit for the new motors, or the new motor and the controller that we bought, is hopefully the kind of getting rid of that whole issue as a whole, and we will have a lot more documentation and support. We have both of these items are they're designed together by the same company, and so we're gonna have the company to support us and the extensive documentation that they provide. Another added benefit is the ability to run under more extreme conditions. Some that are like way higher than what we would be expecting at comp. And another side benefit is the drastic reduction in weight. This new motor is going to be more than 20 pounds lighter than our current motor. And yeah, so these are some specs for the new motor and the new motor controller. That's supposed to say motor controller. And so first steps for this, while we wait for the motor to arrive, is to kind of get all the components needed for the integration kind of finalized before we get the motor. So one of those is the mounting of the motor. And the plan is just to take an 1/8 inch steel plate and just adapt it to the current motor mount. And we ran some FEA simulations to just check for deformation. And according to um, the torque that the motor is going to output, we should kind of fall way under the threshold of what the steel can handle. So yeah, and this is the shaft collar that we designed. It's just to kind of adapt the motor shaft from 10 millimeters to like a 3/4 inch diameter to kind of to implement the 17th tooth sprocket. So our old gear ratio was 30 to 56, and our new one is 17 to 56, and it's adjusted based on the new motor specs, the RPM capabilities, and the crank job. So this is our current steering motor. There's nothing really that's going to change with this. This is just a slide to show you how it works. We use a limit switch on the chassis to calibrate the motor. Calibrate the steering. And yeah, let's see if that's how it works. Um, that's the steering motor on the cart. So our brake actuator. In previous years, we were able to control the actuator, but we were only able to control either fully engaged or fully disengaged. There was no real control of the amount of engagement. Uh, so this year, a big thing that we're gonna try and tackle is implementing a brake sensor to kind of get that feedback from the sensor and the pressure inside the brake reservoir and the brake line, I guess. And so hopefully that'll um, be able to kind of um, give us that input we need to control the braking. Our current computer mount, it, it works, but we are redesigning it in order to mitigate vibration and increase airflow for cooling. Um, because in general, I mean, um, any sort of vibration on a PC is not ideal. Um, and there's also connection issues with the ports and the cables when it's subjected to a lot of vibration. So that's something that we're going to tackle this year. Less three. The e-brake design is not going to change. Still the same from last year. It's just an electromagnet that that holds the tensioning wire um, loose when power is running through. When the e-stop is hit, power gets cut to the magnet, and the tensioning wire tensions the brake bands around the brake drum. Here's the e-brake on the cart. Our current batteries, we have four 12-volt batteries, so it's a 48 volts in series. These batteries currently have no way to quickly disconnect. And so the only way for us to swap these batteries is to take like 20 plus minutes to unscrew all the terminals, unscrew all the mounting brackets, and this is not too ideal. So just for ease of access, for safety, and for just being able to charge these batteries off the cart to increase the runtime of the cart, we're going to design a way to mount the batteries with a quick disconnect so that we can kind of just make it more efficient, more ergonomic, and yeah. So our sensors are pretty much the same as last year. It's just two opti wide angle cameras and our 2D LiDAR and our encoder. The rotary encoder is currently getting input from 3D printed gears that transfer the rotation from the axle to the encoder. This year we're going to try and make that not made out of filament. So we're gonna get them machined or possibly machine them ourselves. Our camera mount is standard, same thing that we had last year. This year we might implement little covers to protect against the sun, overheating and all that. And our LiDAR mount is going to change. We over during comp, we had to kind of do surgery on it because the angle was not where we wanted it to be. And so with the redesign of this mount, we're going to be able to hold that at a steady angle without having to make it look like that. So yeah, next steps for mechanical is just ordering and machining components for the motor integration, designing speed controller mount, and getting the ball rolling with the rest of the projects that need to be done, and testing and troubleshooting along the way.
Hi, here in Cadence. I was going over electrical system for Phoenix. Okay, starting off with our changes that we will be making this year. First we'll be having our physical e-stop cut power to everything, and this is just because our competition has made a requirement now. We will also, like Ever said, be changing from a brush to brushless motor, and electrically this will help hopefully mitigate EMI issues. And then also we will be changing to an accessible wire harness because during competition, anything that happened electrically, we were not able to access it because the wire harness is wrapped in tape, so we could not troubleshoot anything. And that will help a lot moving forward. And then also we would like to move to an easier way to connect and disconnect our batteries. Our electrical system right now, we have a 48-volt system which is powered by our 4 12-volt batteries in series, which is 48 volts, and then that powers our motors, our motor controller, and then our computer. But our computer is connected to a DC to AC inverter, so it's not going to get directly, but and then also we have our 12-volt system, which is powered by a 48-volt to 12-volt DC to DC converter, and that powers our wireless e-stop, our bump sensor, our one of our PCB boards, which is our STM board, and then also our CAN, and then brake, and then our electromagnetic brake. On our 5-volt system, we have our encoder, which is powered by the STM board, and then we also have our cameras, which is powered off the computer USB. So to integrate our new e-stop design, we have switched from 2 48-volt coil system contactors to 2 12-volt coil system contactors, and then also adding 1 48-volt system contactor. And the reason we switched to 2 12-volt system contactors is because the wireless e-stop will now be directly on those contactors, and it only outputs 12 volts. Our wireless e-stop will still cut power to our motors and our electromagnetic brake and our motor controller, and everything else will still stay powered, like the computers, the LiDAR, the PCB boards, and the encoder, things like that. The physical e-stop, however, will cut power to everything. And to do this, we added that third contactor, which is 48-volt coil contactor. And that one, basically all the power from the batteries will be on one terminal, and on the other terminal will be the rest of the system, and that 48 volts will not be allowed across unless the physical e-stop is unpressed. Our EMI concerns right now is that on the cart right now, we do not have our e-stop signal pin plugged in because it's causing EMI problems, so software is not getting updated when the cart is e-stop or on e-stop. But when we plug the signal punch in, that causes the EMI problems, and basically it tells software that the cart is unstop or e-stop incorrectly, so it's not supposed to. With our new e-stop system, our physical e-stop will not be a concern for EMI anymore since it will cut power to everything. But so it might change our EMI problem, but we still think the wireless e-stop might cause EMI, so we'll keep that in mind. Also on the table, there's charts or all the charts and schematics I have on the tables. This is our power distribution. This is basically stating that, like I said earlier, our 4 12-volt batteries, which is the 48 volts, power the entire system. The physical e-stop is allowing that 48 volts to get the power to the rest of the system, and then for the wireless e-stop, that is only allowing the power across to the drive motor, the steering motor, the microcontroller, and the electromagnetic brake. Then also, as I stated earlier, the computer is connected to an DC to AC inverter, and then connected to the computer is the 2 cameras, and then also our TNC which is our interface board, and then on the 48 volts to 12 volt DC converter is everything else that's powered by 12 volts. And then on our STM board, our encoder is getting 5 volts from that. For our power calculations, nothing has really changed except our drive motor and then our motor controller. So for our motor controller, it can operate off of 12 to 52 volts, but we will be operating on 48 volts. And then our max current will, I estimate to be about 150 volts because our drive motor can only take 120, but the maximum it can take is 260, but we won't be taking that much. So, but anyway, the max power is 15,600 watts. And then for our drive motor, it can take 15 to 50 volts, but we've also been powering that 48 volts. And then our max current is 120, and then our max power is 6,000 watts. And then for both of those, I chose a 4-gauge wire. This is an overview of our 48 volt system. Mainly the things I've changed is the motor and then the e-stop. So that's right here. And this is our 12 volt system, and nothing's really changed on here much except that now the wireless e-stop is connected to the system contactor. And then this is our motor harness design. The drive motor is connected to the motor controller via the 3 phases. It's also connected to a negative terminal. Then we have our RS-232 to USB connected to the computer so it can communicate. And then we also have this diode and your resistor on here because that's what is required for our motor. Our next steps moving forward will be to test our our e-stop design and then integrate it, and then check to see what has changed about our EMI issues, and then after that we will test and integrate our motor harness design, and then also test EMI again to see if there's going to change. Then after that, we'll like to incorporate our battery connectors so it will be easier to disconnect them.
Now come for the fun part. In my thing. All right. A brief review. Phoenix is the PC for all high-level autonomous. All of our software is within ROS2, Humble, and Ubuntu 2204. This stack, besides the common filter, which is above my pay grade, is entirely written in-house. All right, changes this year. They removed cones from the track. And that's what detection was last year. So we have to change it. So we can deal with grass, we can deal with pavement, we can deal with white lines. And I chose white lines. So we have to find a way to detect these lane markers and then treat them as polynomials. This allows for geometric information for planning. And then we take those polynomials and we create a path planner with them. So this is our last year's node graph, lovely designed by Andy. And I'm only going to change it a little bit. I'm going to remove the depth data because with cones, you need depth data. It was required for what we were doing. Now that we don't have them, we don't need it, and it was a little bit shaky. And because the world's obviously flat, we can treat it as such. It's a joke, but just in front of us, we can treat the world as flat to get our depth instead of dealing with potentially shaky depth data. And then also we're going to remove the object tracker because, yet again, with cones, we needed this. Without cones, it doesn't work for its purpose. And for our algorithm, it is not necessary. So this is our new node graph with those removed. And this is where the software side is doing our redesign or our updates with the object detector, the line detector, and the concatenator and the planer. Mainly what we're going to focus on is the detector and the planer today. The concatenator is only going to have minor changes to deal with our new design. All right, for our simulation, I'm going to have Derek come up here and talk about it because he designed our new map.
So we missed it. We are not using Gazebo anymore. We are in fact switching over to Weebox, which is a different simulator. So it's a commercial simulator which was open source in 2019 and has excellent ROS2 support. That allows us for both native control of Weebox and ROS nodes. It's easy to use and has really good performance. And its maturity means it addresses most of our concerns. And one of the really big things I think is that it supports acronym vehicles. So Gazebo has only support for twist commands, so that's pretty much for your ARM manipulators. Phoenix is not an ARM manipulator, so we need something that supports acronym vehicles, like cars. So these are just a few snippets of the updated simulation. One of the key things that we wanted to consider was making sure that sim is accurate to the best of our ability because, well, we want to consider if we're looking for white lines, we need to make sure we can consider all of the white objects or white things in sim at competition. And so that includes the finish line, that includes the dashed lines, that includes the white lines on the tracks, even the white sun banner that's also there as well. Some of the tents were white as well, so you want to also consider all the possible edge cases in sim for real world. This is just a little simulation walkthrough. We can kind of see our updated model of Phoenix. The tent, little person over there, our tent with amazing Michigan logo. It's cool. So this is relatively accurate simulation. Yeah. There's a bunch of also white trucks and white vans that I also was considering to include that we might confuse it with a white line. I don't know. I just figured it'd be good just in case to think about it. So, sweet.
The more the merrier. Thank you, Derek.
Yep.
All right, perception. Great. All right. Reminder: we have 2 cameras. Last fall when we did testing and simulation, we realized if we use 1 camera, we lose an edge, we lose a side. Simple fix: have 2 cameras, and it worked. So we're keeping it. This is how it looked last time we collected data last weekend. Cool. So last year, our simulation on the left, actual competition on the right. This is what it looked like. We were using those cones to detect where we're at. You have your cones on your left, you have your cones on your right, you classify them, you midpoint formula, you drive through. Okay? To get rid of cones, what we do now? We have white lines. So, we detect these lines and we transform those into 3rd-degree polynomials. Now, how do we do that? So, the idea behind this is create a form of modular design where the output is the same, and that means that different teams can try out different methods as long as they have the same output, like this graph here. Whether you have an AI machine learning team, whether you have OpenCV computer processing methods, as long as at the end of the day, you have a polynomial left, you have a polynomial right. As long as you get that, doesn't really matter to me how you do it, but these are those methods. These are the teams that we have. We can test them out using the data that we've collected in our simulation and maybe other things outside of there as well. We can plug it in and see how it performs. And that's the idea. So, general structure for how you might do this in OpenCV. Yet again, this is not how we're doing it. teams can they have their own freedom, but this is generally a way of doing it. When you're dealing with white lines, converting it to grayscale is recommended compared to something like HSV values. Ideally, applying some type of adaptive thresholding depending on if it's like really sunny or time of day, is it overcast, and then functions to help whether that's blurring or with any clutter. That OpenCV is good for that. And then popular candy edge detection. That is at your bottom right of your screen. That's what it looks like. And then when we use candy edge, you can extract these points from those white lines, and then you can get those points and apply polynomial regression. And the idea is you have all these points and you plug it into a Python function that already exists and we've already tested, and it puts it into a line. This line then would go to our planner, which we'll go to in a little bit, but before we go there, I want to invite Jay up here to talk about the AI side of detection.
So I'm Jay. I'm a grad student, and my major is artificial intelligence. So this time we are planning to head into the world of AI for Phoenix because it opens up a lot of new opportunities. You can generalize well. You can detect curves, line or no line. You still have a path. So the main reasons that we're going for is so that you can detect lines in low lit areas, and also we will be able to get fast inference times with good models. So it would look something like this. So for the data, we are either planning to take the videos that were shot by the team, or take an already labeled data set by Bosch. It's kind of an open challenge. Anyone can use a data set to make a model. Whichever model is the best, they kind of win. So this is a challenge. They have 100,000 annotated images, so you can make a model of your own and submit to them. So the most popular model choice for this lane detection or line detection or curve detection is LaneNet. It was primarily made for this, and a lot of automotive companies also use this right now. And it's open to use for anyone. It's not open source, but then yeah, it's open to use to anyone. And the reason is it's light on the hardware, it's efficient, and gives relatively good inference time, close to 0.0007 seconds. So this is kind of the neural network behind the model. So first, we'll be taking the input image and then downsizing it using the max pool layers and adding a bunch of filters to detect diagonal lines, straight lines, curved lines. So the convolutional layers are for the filters. The network tries different filters to get, let's call the feature extraction. So after doing it for 5 times, the neural network again upsamples it, which is a part of data augmentation. It upsamples it, uses dropout to avoid overlearning and overfitting, and then gives you an output using the softmax layer. So the aim is to get coordinates of the pixels and then convert it to, as Jared said, left polynomial and right polynomial for the path planner to succeed at the task.
Alright, thank you, Jay. So real quick, just quick review of perception. What do we have? What do we need to do? We have white lines. White lane lines. Alright, what's the goal? Well, we want to create polynomials out of those lines. And then we went through those methods of doing so. OpenCV techniques and functions, and there's a million of them. And then an AI team. And we have both of these working, and we can test both and see how it works, and then integrate what works with that. And that's the review for the perception side. For the planning side, I'll have Alex come up and present.
So, hi. We have a relatively simple job description compared to AI and OpenCV. We will be taking in the polynomials to give us, and we're essentially generating a task problem. We will be doing this by generating midpoints given these polynomials. As seen here, blue and red for their respective polynomials. The biggest thing is that we'll be planning this path every time we get new information, which should be relatively quickly, hopefully. Um, we have a few outcomes that we're taking for where we're gonna get the x values from our polynomials, whether we're gonna do kind of just wait, hold on. This is oh, okay. I guess that's I didn't get included. Oh well. So when it comes to sampling, we're either going to be just having a fixed interval that we'll be sampling from to generate our points, or we can generate a function given how sloped or polynomial it is. We can use a function to generate those x values. Essentially, we'll be taking the derivative at that point to which way our vector needs to go in the track, and from there we'll just track it 7 feet. So it's still like very consistent 14 feet across the track. And the biggest advantage that we have, especially over last year, is that we good on corners. We don't need one side to generate a midpoint from, since we can only just use, or sorry, we don't need both sides to generate midpoints to drive to, because last year we were struggling to see the other side of the cones. We won't have to worry about this year. We can just use a single polynomial to get a path line.
All right, Derek, you want to come up and talk about tiny part?
So, Tiny Kirk is still continuing this year. New members now actually start out in Tiny Park, which is now a beginner level project where one will join a group of engineers, fellow engineers, to build a Thomas RC car that would be traveling in a walled circuit. So the teams will be provided with RC tracks / 2-wheel drive RC truck, an STM32 microcontroller, an LV06 2D LiDAR. So they'll be basically working with a little tiny ESC and a little servo motor that pretty much mimics Phoenix as with their servo motor, ESC, and sensing capabilities. So those who are interested in mechanical will learn how to use SolidWorks and get their first-hand experience in dimensioning accurately by designing a LiDAR cage. So electrical students will be learning how to draw and interpreting circuit diagrams and wiring that embedded system. Software interested teammates will learn how to develop an algorithm in C++ and work with a basic autonomous stack to get Tiny Park moving on its own. And so this is all using just the LiDAR system for autonomy. Currently, we have 88% retention rate in Tiny Cart, which is pretty high. Currently, we have one software team who's actually perfecting their algorithm to successfully navigate. So I saw them kind of moving around, and they're just trying to get those turns, so they don't really hit the corners. But for the most part, they do have them navigating our Tiny Cart. There are 12 total teams that we have. And at this point, all electrical and mechanical members are now working on Phoenix. And some software interested members are starting to work on Phoenix as well. This is all within a 2-month time frame. I'm still wondering if I should just kind of let them go until the end of October and say, okay, whatever you accomplished was great, and now we'll just simply shift you over to Phoenix, where we need your help pretty much we need all the manpower we can possibly get. So pretty much moving everybody from Time Card to Phoenix, maybe early November would be probably ideal. Yes.
All right. So in general, that's it. Unless there's any of you guys have anything else to say, how we're going to do this, generally speaking, is go from top to bottom. So at first, we're going to just answer any general questions on design, scope, and power. And then we'll go down from there from software, hardware, and electrical. Do any of you guys need to add before we go through those? No? Sure. Okay. So I guess at this point we can open the floor up to general questions on design, scope, and competition, and other stuff like that.
For the top, said there was
pre-planning and then like live competitions? Is it either or? Do you both?
You can do both. We don't have GPS on the car at the moment. Not only that, we'd have to do a bunch of other stuff too to get it working. At the moment, we just decided to do the reactive category because we were doing last time, and it's what we're kind of perfecting right now. I think large scope or future scope is well for the competition itself is they want it to be combined into one eventually where carts are racing each other. So it'd be a combination of both kind of mapping GPS and reactive. Right now, we're just trying to get the reactive down. Because the idea in general was eventually they want to get rid of cones, and now they got rid of cones. Now we have to figure out how to work without those, and then eventually try to integrate a GPS and do that kind of stuff. But for now, we're only sticking up for one. Andy?
I guess did competition decide on that already then? Because I know they were talking about.
I mean, that's what Stanford has told me. It's what they're like.
Oh.
The idea is. I mean,
Yeah, I don't know. They're
that's
just
nothing official, but that's the idea.
okay. Cool. Yeah, I was gonna say last year at least you could actually compete in both because
Oh, these are short teams that compete in both. So I'm assuming this year they could do the same. They haven't told us you can't. We're just choosing either one, but we don't have the scope to do both.
you could technically enter in GPS though.
We could, but we
You don't
don't.
have to, but you could.
We could, but can is the
Fair enough.
question.
Can.
So, big thing on a general aspect. One thing that I feel like I would like to see more in the presentation is a lot more on the project, on the whole team project planning aspect. So deliverables, like basic Gantt chart of deliverables and what days they're supposed to be due and times and all that stuff. I think at this point it would have been helpful to have or at least see you may have something developed internally, but just saying like I need to have this certain project or this aspect of my one project and this team done by this date, or else it will hold up things elsewhere. It also helps ensure that the team is on track. We're lucky that Andrew Johnson is not here because he would point on this till the sun goes down.
So we don't have it on the presentation, which probably should have. We do have a Gantt chart.
I'm sure. I'm just saying it from someone who's coming in looking, it would be while I assume you have something on a design review, I would have liked to see it.
Yeah.
I agree with you. Funny enough, Andrew Johnson's the one who pushed us to create the
Oh,
Gantt chart.
I know.
So, but I agree with you. I understand. We should, probably should have.
We do have a slide that has dates.
We have a slide that has dates, but you were looking for a little bit more than that, right? You were looking for like,
I mean,
specifically when this will be done, or like
and
when
broken
this-
down by pretty much each
Yeah.
team and each.
Like for example, like for the software for the Gantt chart, right? I have 7 weeks blocked off, which I think it ends in early December, where I want the planning and the detection algorithms to be set, and then we can test them and make sure they're done by this certain time. So we have that, but we didn't have it.
No. Sure.
Anything else for general questions, design scope, comp? Is there anything in the chat or chance? No. Okay. Software questions.
I guess I'll yield to anyone else if anyone else has questions first. I do have them, but yes, okay, I'll go. I guess probably the most interesting question for where did I put it? I think slide 82. I think this is. The one with the different CV types. It's so when you're saying you have all these different approaches, are you? It's cool to do different approaches. I think that's a neat idea. Obviously, it's very possible. Are you approaching this more as a structurally? You just have a bunch of different nodes you swap out. You have a bunch of different modules. Are you doing all of them at once and then doing consensus, or like what's the?
Kind of. Okay, sorry. That's something I now realize I didn't say. one of these will be chosen, one of them will be.
Okay.
So it's kind of like you have the different detection strategies. We'll have like each just one like each file that's each strategy. You can just switch it out
Okay.
anytime. So yeah, only one of these they're not used in combination. So just one. And this lets everyone try their own methods, try it on it, see how it goes. Teams can maybe compare what worked, what didn't. That also gives the AI students something to work on too, and then we can see how that works out too. Yeah.
Also, is there a CV team too, or is that just like an example of like you could have multiple teams? Just
Well, there's enough people that having one team probably wouldn't work super. So we have a CV team,
Mhm.
but it's be too many people to work on just one method. So my idea is we're gonna have certain people working together to use the data we've collected to try to develop something, and they can try to develop something. Maybe I try to develop something. Hopefully they don't. But like, and then we can kind of see how those work together. Or yeah, does that make sense?
Yeah, no, I see what you're doing. And I guess I think it's literally the next slide. Maybe. I think. I guess something I'll just kind of throw out there. You probably did consider this, but it's just not on your salt save anyways. Just be careful with a normal approach like this, or like a conventional approach. Just because like all this is like very doable. What we ran into with Ohm was just anytime there's shadows and light. I know you're tested for this, but just I guess is that something that there's been shadow trying to solve?
Yeah.
Or is that just not really considered for this approach?
So
The lighting issues? Is that what you're asking specifically?
Yeah, like specifically like really harsh lighting or like really hard like at IGBC when I was trying this of there was like a cone casting a harsh shadow with harsh lighting. So it's really bright and with really dark spots. So you can't just do like a global thresholding thing.
Right.
Which is what I was trying at the time, and that's what's on the
So
slide. Looks like.
yes, that's been in our conversation. Um, First off, it would be cool. That's one of the ideas I would like behind potentially using AI at some point. But then, second, that is definitely one of the main things we're testing for in the CD development. And that's why like in our test data that we're collecting, we're getting shadows on the lines, we're trying to get different lighting because that's what we're trying to kind of fight because this kind of stuff is done it's not a new problem, right? So we're gonna try to do our best to do that. And there are forms of dynamic thresholding. I haven't looked into it me specifically too much, but it is out there. Um, so that is the goal. Obviously, it's the goal. But yeah, if you have any suggestions of how to deal with that,
I wish. I mean, so that's the problem with some for you, so
I mean, in some ways, I know we've talked about this before, but that's why we're trying both approaches. That's why we're trying different teams. That's where we'll have feedback with each other. That's kind of the issue we're trying to solve with all of this.
I believe what was it? I don't. It's been a minute. It's a little outside of my realm of expertise. My apologies. I did not pay attention when I took computer vision at this university. Um, I know probably the only best possible, well, one potential way to help get around some of this stuff is not is more so being able to accommodate for it and the path planning using memory of what states have been working and not. However, that's not easy as your vehicle is moving. But that might be something to consider because it may just be impossible using canny edge detection to be able to have my perfect white lines in every circumstance.
Yeah.
Okay. Because I remember, because in my class it was a paint on on perfectly lit images. So
Yeah. You want to say something?
Yeah, so good input, and we had some of these discussions early on, and we come up with different possibilities for solutions.
Yep.
And that's kind of what led us to the modular approach. So as people come up with their own solution states, then we can try some of those out. But
Yep.
we also had some within the design review, we talked about things like windowing and stuff. So
Yep.
once we've established where we think the line is, we can hopefully ignore some of the harsher lines. So we have some ideas. I think the idea of the modular approach allows us to try different ideas, plug and play, and find out.
That leads into a couple other things I was going to mention.
Um, so on the modular approach, this would be kind of a later stage thing. If I all three or two or there's more than one method is the team determined working, it may be possible to try to do some sort of statistical analysis between the two and determine which one is has a best confidence and stuff like that. But that's probably like way down the road. Using multiple data input sources, but one thing that would be I think nice for CDR when it comes to the path planning, especially keeping a lot of these things in mind. You guys have described it seems fairly well what you want to do for path planning, but I think it would be nice to actually show actually control system models of what your intentions are. Part of it, it lets you know exactly what numbers you are planning or numbers or variables you want to use as your input sources has it perfectly lined out and clear, and it also helps get some sort of sense of planning and transparency on exactly what that you are trying to do. I know, obviously, it could just be charts on the screen saying what your code's doing. If you want to go a step above, we can look into Simulink Coder where you can export Simulink into different C code or C++ code and whatnot, but that can be a pain sometimes.
Yeah, we'll keep that in mind.
Something to keep in mind.
Yeah, appreciate that. One of my comments based on all that is this structure, like even the question you asked Andy, it is definitely general, and that's kind of this is not anyone's method. This is, as you said, a traditional method, and I just put this up here as a kind of showing this can be done in this way, but everyone kind of has their freedom to do it, which way whatever way they.
Yeah. No, cool. I mean, it seems like you have a lot of people at this, which is great.
Yeah.
But go. No, that's
It's been actually really nice in that way.
Oh.
Ollie, you have a question?
No, yeah, you just said what I was about to say.
Cool.
Yeah.
I know we have some questions in the chat.
Yes, I do. So there's a question, why not use a single wide FOV angle camera instead of two?
So both of our cameras are both wide angle cameras. And so actually this is a question I'm gonna ask Andy real quick. When we were using one camera, was that a wide angle?
I think he just told me the
I
answer.
was gonna say, okay, I'll just tell you the answer. The answer is that modeling the distortion on what would effectively be a fisheye lens is an absolute nightmare, and it's easier to just do it this way because you'd have to have a really special camera you need to write a ROS driver for, or something with like an interchangeable lens, which also doesn't have a ROS driver for. And so it's easier just to get this one that's wide enough and just have multiple than to try to have one gigantic fisheye or like 360 lens and deal with the awful distortion modeling because we do projection and you mentioned this as well, like not using the depth. That all relies on just using the geometry. And so you need to model the distortion, which is
a lot of it has to do with the distortion, and it's an easier fix to just have the two cameras.
Yeah, I mean, it's clearly technically possible. People do it certainly, but
is it within the abilities of us to do?
Yeah,
it's easier to do it that way. Okay,
that's why I chose it. At least you could.
Yeah,
you can.
I mean, in my opinion, if it ain't broke, you know what I mean.
Yeah.
Hopefully that answers your question. If it doesn't, we can also have a follow-up question.
Cool.
Sure. And there's another question in chat.
It seems like it was answered within chat, but I can ask it. If line detection needs a black and white image, why use a color camera?
Great question.
Fortunately, it doesn't work that way.
I mean, you can obviously just add filters and just kind of make it black and white. I mean, it's something we already have. We already have these cameras. We're not gonna purchase just a black and white. Like, there's no problem.
I mean, and yeah, in that way, it's kind of we have two nice cameras. We also have backups of these cameras too. We can use to test on, and they're decent cameras too. And I think applying a filter to it, unless there's some benefit that I am currently not aware of, because this is actually something I haven't really researched. So if there's something I'm just not seeing, you can let me know. But it seems like with the qualities of our cameras and just apply a filter, it should be okay.
Yeah, also Jared, I would like to add that some neural networks would like three-dimensional image, so we need the three channels. So some normal image processing methods would require black and grayscaled images,
but most of the neural networks, modern neural networks would require three channels, so that's
I
why
see
you
what you're
use the
saying.
RGB.
So what you're saying is maybe for black and white, we can use black and white camera, but for doing AI stuff or anything else, we really do need the RGB.
Yeah, and
Yeah.
the lane that he mentioned, and Diolo, and most of the modular neural networks requires a three-dimensional input.
Okay, I see what you're saying. Okay.
I guess I'll also point out, just for future use for yourself as well, you actually do have four black and white cameras already, because the depth cameras can be seen. We don't use it, but the depth cameras are just a pair of black and white cameras. So if you ever wanted those, and they run at a super high frame rate, you actually already have them. So you could use them as
I
is.
didn't know that.
So
Okay,
yeah,
cool.
just something to think about. You just have to expose them. to
Are
the
you
rest,
on the
right?
wrong side of the presentation?
Yes.
Okay, cool. I'll keep that in mind.
Yeah.
Cool. Is there anything else in chat?
Nope.
At the moment? No. Okay. Any more questions on software?
This is
So-
software questions.
Software.
So
questions?
related to that, if you anticipate the challenge changing in the future, are you planning on like capturing more data than you use now to help inform decisions later?
So you're saying
Store all the depth data, even if you're not going to use it. If you have any other sensors,
Yes.
thermal, whatever. 3D
so
LiDAR.
we're still recording everything. We're only using certain things. Yeah, like when we recorded, like I recorded that. Like we recorded things and we can use that still. But I'm not gonna use it. So we're recording it, we're putting it into our Dropbox the university gave us, pamphlet and Google Drive anymore. And we'll just keep putting more and more data there and hopefully we can use that going forward. Especially if it seems like it's gonna be standardized in the sense that we can pretty much always use these white lines, like they're not gonna take those away. So the more data that we collect, even when we're at Purdue, maybe we can collect data, which would be great, and then we can use that and more going forward. So
And then another for the other thing for the ML model, if you use the llama data set, I don't know exactly what it looks like. Do you think it'll be close enough to what you're getting out of the cart images? What it'll be useful?
Didn't get you.
I'm gonna go back to
Don't
this.
get you.
Oh, sorry.
Yeah.
Like using the llama data set,
To the
do
side
you
of
think it's close
gifts.
enough in image quality and
Yes,
like, should
it's
there some, you know,
the resolution is close to 1200 by 1400. So the neural network will be 1200 by 700. So we will be rescaling it to 640 by 640. That's like a good balance for downsizing it. Yeah, so that should be pretty good.
Yes, I have just two more things I promise. One on slide 94, just for Alex here.
Oh, hey, that's me.
Yes. And this is the first time I'm seeing this as well, of the point something thing. I guess, is there a reason you're doing this instead of just walking like X distance along each line, this like derivative thing? Because I think that might honestly work, but I don't
I mean,
quite understand the motivation, I guess.
so what do you mean by walking along the line?
Like just like because what we did last year is just like a naive approach of well, I mean, it was a bit different because we that were bounding us. You can sample however you want it's a line, but just like being like move X units along each line and just get the midpoints along there.
That's kind of what I was doing with the X sampling. The reason for the derivative is because if we have a single line, I wanted to preserve the integrity of that curve, and I felt the best way to do that was to just derive at an individual point, since the orthogonal line from there is going to be projected pretty nicely. I don't know how to actually shrink a polynomial and still maintain the integrity of that curve, so I was thinking the derivative would be an approach that I could solve.
So it's trying to match one side being smaller than the other, basically.
Yeah,
Sounds like
essentially.
Okay, cool.
That's the reason for the derivative. The sampling part is going to be, I think, in the real challenge there is just like how to sample.
It sounds like you've decided from what you said. No, that's cool. No, that I like that. That's nice. And then I guess my last thing is just kind of a shout out to Sim being crazy. I don't know how. I don't know if you did this in the last like week, but
Yeah, I did.
that is so impressive. Like, crazy. Like that, and especially adding objects that are also waiting in the background and stuff. Like, seriously, that this is easily the best sim I've seen out of ISC. Like, it's crazy. So, just kudos to that.
Did you put the old Phoenix sim on top?
So yeah, you can see. We can go see it. See him. Here he is.
Yeah.
He's doing a little camo in the sim. But yeah,
That's what we had before.
yeah, it was a box. And
A
now
box.
and now it's a pretty detailed. I actually dimensioned Phoenix, so this is actually true to size.
And he created this week. This is very real.
Do make sure you match the URD up to that. But I mean, it's gorgeous. It's like if you change the model in Sim, make sure you change the model in ROS, or else it'll not be accurate. You won't get accurate data.
Understood. I
Just
will
look at that.
consider that. Yes.
Yeah. But you should make it accurate anyway. So like,
Yeah.
do that.
Yeah.
But still, yeah, this is incredible work.
And one of the things that I did actually last minute was the finish line. So I figured, hey, that's actually really important. There exists a finish line on the track. And it kind of looks a little bit, it could be perceived as a dotted line.
Yeah.
Because it's black, white, black, white. So I'm thinking, well, that is pretty important for AI people to kind of take a look at for an edge case list such as that finish line. We don't want to not cross the finish line. That would be terrible. We would absolutely want to just kind of approach it and be like, oh, I don't know if I want to cross this dotted line kind of thing.
Hard to tell, but like this is the actual track, and we will have these dotted lines in 2 locations. So we also have to make sure that our detection methods account for this.
I do have a comment from the chat.
Yep.
That there used to be a Unity sim a long time ago as well. This is nicer. Ohm at one point failed because the money barrel was confused as a do not cross white line.
Do I not know what a money barrel is?
Probably construction barrels, what they're talking about. Like the ones on the road, because those have the white stripes.
Okay.
I think I found a video of that actually.
Just the shadow under the bridge, we're also going to have to
Oh, yeah.
make sure that, because that's inevitable, no matter really what the lighting is. Make sure that our perception
Also, yes,
is that.
very good. I had to change the exact color underneath the grid because Sim would actually just paint it completely white and ignore the shadow. So I actually had to adjust that and made it its own thing. So now it actually looks like a shadow.
Crazy. Yeah, that brings up another idea or another thing I was going to mention when it came to a lot of the path planning and stuff like that. It may not be a bad idea for those working on the I think it would be a mixture of both the white line or the CV teams as well as the path planning to not just for your polynomials, but to separate them from the short-term distance from your car. So like the angle is fairly wide, and as well as your long-term distances. So for example, something like that bridge there, it may affect your short-term, but your long-term, it would say it's okay. Then try to find some sense of meaning between which one you would trust more in any given instance. Not the numbers and statistics for sure. But
Makes sense.
I mean, I've seen not quite applied to this type of stuff before. I've seen this is on a different type of scale, but for different types of projects. But in theory, I've seen stuff where you would basically have your entire view stored into a basically was it a moving was it I would say a queue, but basically like a queue where your distance is stored in a large array and progressively moves shorter and make meaning on how far each of them is in between and not just trust one set that you've account you one set you can trust or one data point, but rather try to analyze all possible points that you can visually detect along in front of you. So
I see.
a lot of arrays and statistics, but
Okay. Yeah, I'll keep that in mind.
one more thing to keep in mind. I don't know how your software performed last year. It seems like the PC is pretty beefy. But like if you're at 80% utilization, then don't plan for you to be like, oh, we'll just drop it in and we'll be fine. So seems like you shouldn't be at that point. But
From my understanding, the Dell PC can pretty much handle anything we can throw at it.
I guess I will add to that just for you. I guess. Do you know how big the LaneNet model is? Just out of curiosity.
No, I'm not aware of how big it is. But then, yeah, it is the most efficient on embedded hardware, so I think it should be good on the PC.
Yeah, I was just curious. It's 640 by
Yes.
640. It's just like huge. So
No, 6 yeah, it's not actually very small, but it's not huge as well. I mean, you can train bigger resolutions, but then 646 by 640 is like a good
wait,
balance.
so that's good. I've used Yellow V8 on that in the
Yes.
past, and it
Yes.
worked well enough, but you had to use the smaller one. So yeah,
Yes.
just curious.
Yeah.
Yeah.
Yeah, YOLO uses 640 by 640 by default. That's why I chose 640. Yeah.
Oh, nice. Any more software questions? Nothing in the chat?
They reference. They're showing me a YouTube video of the barrel.
Who is this in the chat? Oh,
Christian.
Oh,
That is the one I found. Okay, I have to look at this now. Oh, I see.
with Kristen Brian.
Yes.
Yeah.
Thank you for this. I appreciate it.
Okay, if you're good on software, we can also you can text me or talk to me later at any time too. But what's the next one? Is it electrical or mechanical? Hardware. That's what we call it. Cool. Have fun.
got any questions? Have the LiDAR mounts, you want to do like a fixed angle? Should you choose to change that in the future? Do you want it to be like
So I thought about that. I'm not entirely sure at the moment, but like if we can figure out a way to kind of have it like reliably stay in the same position while also being able to move it, that might be something that we think about. But generally, we just want it to be level. So
makes sense?
anything else? Last chance. No. Sweet. I guess we're good. Move on to electrical.
I'll ask a question.
Let's go.
Your pressure sensor,
Yeah.
is that something you guys have somewhat decided on, or at least looked into like parts? I know you had something on the side.
Yeah. We looked into it. However, we haven't decided quite yet. We're not. Where is it? I kind of want to get a balance between Whoa, where is it? Oh, so right now we've only really looked into one. But I also want to make sure that the pricing is kind of not horrendous because I saw one that's like industrial grade. It's like I think it's like $1,300, and I don't think that's reasonable. So there have been two different kinds, I guess, that we've looked into. One that's kind of just gonna fit into this T joint, like that one, and just kind of screw into a different like a cross joint, or one that looks like that one, where it's kind of just gonna fit underneath. And you can see that the brake line kind of runs through the bottom of that little space, and so that's perfect. Except the guy who looked into it, I haven't heard back about the price, so we'll see. Nothing's been decided yet, though. So, cool. Anything else? Going once. Okay. Seriously.
Later.
Is there any electrical questions?
Just you've got I'm not complaining, but you got the like battery to AC adapter to PC. So that's like a little goofy in my opinion. Instead of like just a separate voltage regulator, just laptop.
I mean, going to an inverter like that's not the worst. It can be, it may be more efficient to go to a converter, but realistically, or just using a DC converter, but realistically, the Dell Mini PC has its own power cable and its own power brick and stuff. Having it go to a 120-volt inverter, which I assume that's what it is, not a 48-volt inverter, because I really hope you're not powering it off 48 volts AC.
It'd only be proper ISC legacy to have DC to AC
Sure.
inverters and
Yeah.
DC to DC converter.
And then also so you've got the voltages spec'd out for the like motor and the motor controller. That's where you want it to be. That's all for performance of those components or other limitations.
I try to base it off on what it will perform as. Because especially for the motor controller, they can take a lot more amps, even more than I put on there. But we won't be using on that, so I try to base it off what it will.
Yep. I guess when it comes to that, do you know the discharge rate of your batteries you were using? Because I think that was, it could have been a long time, but the maximum continuous load that your batteries can discharge is important. Realistically, for this competition, you are probably not going to drive your motors probably nowhere even past 15%, just because you're going to be more reliant on the camera and all that, and your system to even let it go before you can even before anything else. But when you are trying to move to higher voltages or higher speeds, I don't know if that type of battery would be the best when it comes to that much of a continuous discharge. But maybe I'm wrong. I don't know off the top of my head. So
I do not know the discharge rate right now, but I will look into that. Other questions in the chat room?
the biggest thing for most of mine, I would probably need to have a one-on-one with you for a lot of it. But I think the biggest summary is I would strongly encourage learning the use of some sort of schematic making or ECAD tool. Uh, the ISC diagrams of old cannot keep working with this. Um, I understand trying, but it just what this is here does not accurately lay out what you're trying to show. And additionally, with the presentation, it seemed fairly confusing on which device and which board does what. I believe you guys are still using the interface board from a TNC, using an encoder steering throttle board with the STM, but at the same time, the motor controller you're using is connected to your EC and has no input to these, so it's confusing mess. I'd like to have a one-on-one at some point to try to get an idea of what's going on and uh, help get a better idea on your guys' end as well.
Is there any general questions on anything? Any team, any ISC, tiny car project?
Tiny car question. So you've got the lidar problem. If there's ever a lot of people who ever think you would do half them doing lidar, half doing like white line detection or something else, help prep for Phoenix integration.
That would help
It's an interesting idea.
too. It's actually pretty easy to implement, so we would definitely consider that. I mean, even right now, with all these people working with basically this like the algorithm that we're basically using for Phoenix, they already have a really good understanding of what Phoenix is all about. So adding on to white line perception would actually benefit them a lot more and us as well. So I think that's actually a good point. We were using LiDAR. We could be still using LiDAR. So we could just have him start out with LiDAR for a few moments and then have him just be switched to the camera and do white lines. That'd be cool.
In the future, though, LiDAR will be really important for our members to be comfortable with because basically, once we get the white line detection down, we're going to want to move on towards object avoidance, which is going to be almost entirely.
Oh, you know what? I might just talk about that for a moment. So, there will be objects on the road in our competition. We didn't talk about it because we decided to not have that in scope. And what I mean by this is what we want to make sure we do is what we didn't do last year is make it down and then turn. We want to be able to have Phoenix reliably go down a straight and then turn. And so once we're able to do that, or if we have extra capacity, then we can go towards object avoidance. But we don't want to go too far out, and we want to make sure that we are able to take the next step. And so right now, it's out of scope. It's still something we would like to do because it's still we can't. Well, who knows what would happen? But right now, that is not within our current priority. But we would like to get there. And LiDAR is going to be one of our biggest helps for that, especially without cones. Because before, the LiDAR would pick up cones. And now it would only pick up boxes, so that actually might make it easier. My hope on the software side is we're able to do that. But right now, my priority is what I did.
Quick question for Mika.
Yes.
Do we plan on having any like official race? So I feel like there should be some incentive for.
I want to do a race towards the end of this month. We already have one team ready for pretty much to compete. But that's out of 12 teams, so it might be a while. It might be maybe November since we'll see. It'll probably be like a time trial race. Basically the first team to finish gets his race. We get a time trial there, and then we just continue there. That'd probably be the best way to go about this. That we can upload these members to your team as quickly as possible.
For your last point there, I want to applaud you because it's probably the first time I've heard any of these sim teams at the University of Michigan Dearborn. I realize and understand that it is not always the best idea to try and achieve everything, but rather make a real, focusable, attainable goal for their team to work on. I will not throw shit at any team or teams in particular, but for example, that appreciate that.
Any other questions?
We also got kudos in chat for still as well. First.
Oh, Andrew.
Does Andrew have anything to add?
Oh,
It's the kudos for still.
Applauding us for the basics.
All right.
Well, does Andrew have anything to add? Did he read the slides?
He just jumped.
Oh, he just jumped. We'll give him a moment. We'll give him a moment.
He's gonna work back.
Just survive.
Oh, he's gonna survive. Okay.
He missed it all. It says.
Okay.
So he didn't get the slides.
Oh, okay.
Oh, yeah. I think he does survive.
All right. Any last questions? Anything at all?
Awesome. Thank you guys for coming. Really appreciate your feedback.
Thank you guys who are online. Appreciate you.
We have outro music.
Sure.